Marcus rolled his 2015 Ford Fusion into the third bay on a Wednesday afternoon. 2.5-liter Duratec, 168,000 miles. One owner from New, Rochester, New York. Trans was shifting hard from second to third, and the check engine light had been on for about a week. Before he brought it in, he'd done something I want to walk through, because it's the exact reason we're having this conversation. He'd watched a video that told him if he turned the key to the on position, waited 3 seconds, turned it off, waited 5, and repeated the whole sequence, I want to say 15 times, the check engine light would clear itself and the trans would go back to shifting normally. He tried it. He tried it again. He was on cycle number 15 when he decided the trick wasn't working and drove over. The trans was still shifting hard when he pulled into the bay. There's a whole category of videos on my feed, and probably yours, that promise a reset trick will fix 99% of car problems for free. Some of those tricks are real diagnostic procedures, documented in factory service manuals, used by shops with proper scan tools, effective when performed correctly. Some of them are marketing myths that don't do anything and just make you feel like you did something. And one of them, if you follow it, will make you less safe in a crash. I want to walk through 11 of the most repeated reset tricks and sort them into 3 tiers. Tier 1, resets that actually work. Tier 2, resets that work partially or only in specific situations. Tier 3, resets that are pure marketing. And then, one hard reject, where the answer is not to reset it at all, but to diagnose what's wrong. I'll explain the mechanism behind each one, because that's what tells you whether a reset makes physical sense on your car, or whether it's just choreography. Stay through to Tier 3 at about 18 minutes in. That's the 3 resets the compilation videos push hardest, that either do nothing or actively damage the module they claim to fix. I've had customers come in with dead body control modules after following one of them literally. I'll name the 3 and show what physically happens inside the module when you run the wrong sequence. If you take one thing from this walkthrough, take the Tier 3 list. That's the one that saved Marcus from a second visit. The reset he almost did next would have bricked his BCM at $900 for a replacement, plus programming. Near the end, I show the 6-minute test Marcus's shop should have run before recommending anything. Tier 1, resets that actually work. Reset number 1, throttle body relearn. This one is real. It's documented across most major manufacturers. Toyota has service bulletins covering it. Honda includes the procedure in owner's manuals. Ford, GM, Chrysler, all have their own variants. The mechanism is straightforward. Modern engines don't have a cable connecting the accelerator pedal to a mechanical throttle plate. It's all electronic. The pedal has 2 position sensors, the throttle body has 2 position sensors, and the ECM correlates all 4 values every millisecond to decide how far to open the plate. Over time, the throttle body plate builds up carbon deposit at the edge and on the idle air passage. The ECM compensates by adapting its idle position table, memorizing. For this engine, an idle command needs to open the plate a little more than the base value. When you clean the throttle body or replace it, that adaptation is now wrong. The clean plate opens further than the ECM expects. Idle hunts. RPM surges. The car feels wrong for the first 100 miles until the ECM learns the new baseline. The relearn tells the ECM to throw away its old table and start over. The procedure varies by manufacturer. On most Honda vehicles, it's the KOEO, Key on, engine off cycle. Turn the key to the on position without cranking. Wait 10 seconds while the ECM enumerates the pedal and throttle sensor positions. Turn the key off. Wait 10 more seconds. Then start the engine. Let it idle at 0 throttle for at least 10 minutes with the AC off and no accessories loading the system. And then a short drive cycle, including a couple of full stops from 30 miles per hour. The ECM watches the new idle for the 10 minutes, samples the plate position, and writes it into the adaptive memory. On most Toyota vehicles, the procedure is similar, but with slightly different timing. On many Fords, you need a scan tool that can command the throttle position learn. On GM, some models require the Tech 2 or a modern equivalent. Here's the practical part the compilation videos leave out. The correct procedure for your specific vehicle is not going to be identical to what any generic reset video shows. Different manufacturers use different key cycle timing, different idle relearn durations, different requirements for accessories being on or off. Honda's 10-second, 10-second, 10-minute procedure is not going to work on a Ford. A Ford's ignition switch key dance procedure won't apply to a Toyota. If you do the wrong car's procedure on your car, you'll get either no relearn, because you didn't hit the trigger the ECM was watching for, or a partial relearn that stabilizes idle at a slightly wrong value. The right way to find your specific procedure is to look up the factory service manual for your year, make, and model. Most manufacturers put the diagnostic procedures online through their service information portals. Some are free for owners. Some require a subscription. ALLDATA and Mitchell both have consumer versions at reasonable monthly rates. Or cheaper. Most makes have active owner forums where the procedure has been posted and cross-referenced with the factory manual page number. Do not just search throttle body reset on YouTube and pick the top result. Do search throttle body relearn 2016 Honda Civic factory procedure, or the equivalent for your specific vehicle. Real fix. Free if you have 10 minutes and a working ignition. Green light. Reset number 2. Transmission adaptive learn. Also real. Also widely misunderstood. Modern automatic transmissions have their own control module, the TCM, Transmission Control Module, and its own adaptive table. Just like the ECM adapts to the throttle body, the TCM adapts to the clutch pack wear inside the transmission. Over years and miles, the clutches wear a little, the accumulator pressures drift, and the TCM slowly adjusts the shift pressures and shift timing to compensate. When you replace clutches or solenoids or rebuild the transmission, that adaptive table is now telling the TCM to shift a worn transmission the way it needed to be shifted 6 months ago. The result is harsh shifts or hunting between gears or delayed engagement. The reset tells the TCM to throw out the adaptive table and relearn from a fresh baseline. Here's where the videos get it wrong. Most of them present the transmission reset as a fix for a hard shifting transmission all by itself. The reset is not a fix. The reset is what you do after the mechanical repair, so the newly repaired transmission can be adapted from a clean slate. If your transmission is shifting hard because a clutch pack is worn or a solenoid is failing, resetting the adaptive memory buys you one shift cycle before the TCM relearns exactly the same bad shift pattern. That's what happened to Marcus. He was watching a video that recommended the transmission reset as a fix for hard shifting. He performed the reset. Battery disconnect, key sequence, whatever the video showed. The trans shifted normally for one drive cycle, and then the TCM readapted to the underlying mechanical issue, and the hard shift came right back. Real procedure, real utility after real repair, not a standalone fix. Green light with a footnote. Reset number 3. Keep alive memory clear via battery disconnect. Also real, but only when you do it correctly. Modern vehicles have a keep alive memory circuit inside the ECM, the TCM, the BCM, and various other modules. When you turn the ignition off, most of what the module is storing gets written to non-volatile EEPROM. But some fast access data, recent fuel trims, recent adaptive corrections, recent trouble code snapshots, is held in RAM that stays powered by a small trickle current from the battery. Cut the battery power for long enough, and that RAM clears. The mechanism people miss is that cutting the battery for 30 seconds isn't long enough. There are capacitors in each module that hold enough charge to keep the RAM alive for several minutes after the battery is disconnected. To fully clear the keep alive memory on most modern cars, you disconnect the negative terminal, wait at least 10 minutes with the key off, and, this is the part the videos get sometimes right and sometimes wrong, press the brake pedal down for 30 seconds during the wait. Pressing the brake activates the brake light circuit and gives the residual capacitor charge a discharge path to ground through the bulb filaments. Without that discharge, some modules can hold their memory for an hour or more. When it's done right, the ECM comes back up with a clean fuel trim table, cleared soft codes, and no recent snapshot data. Some intermittent drivability complaints that were being aggravated by bad adaptive values will clear up. But, and this matters, if the underlying condition is still there, the ECM will readapt to it within a few drive cycles, and the complaint will return. Just like the transmission reset, this is a start-from-scratch tool, not a fix. Real procedure. Documented in every factory service manual. Green light with the same footnote. Reset number 4. Scan tool false code clear. This is the most legitimate reset on the list, and it's also the most useful for the average driver. But you need the right tool. Any code stored in the ECM's diagnostic memory can be cleared by a scan tool over the OBD2 connector. The standard was defined in Society of Automotive Engineers J 1962 for the connector shape and J 1979 for the data protocol. Every U.S. market car from 1996 forward supports it. Every world market car from 2001 forward supports it. When you clear a code, one of 3 things happens. If the underlying condition is still present, the ECM will redetect the fault and set the same code again within a few drive cycles. That tells you the fault is real. If the underlying condition was intermittent, a loose connector that reseated itself, a temperature-related fault that resolved when things warmed up, the code stays cleared and no light comes back on. That tells you it was probably a one-off. And in the third case, if the code was set by something that's since been repaired, you replaced a bad sensor and the code is still stored. Clearing the code lets you verify the repair took. A basic OBD2 scan tool costs $20 to $40. A better one with live data streaming costs $80 to $200. Both will clear codes. Both are more useful than any key cycle reset trick because they actually read what the ECM is complaining about before you decide what to do. Practical guidance on what tool to buy because the ranges vary a lot. Under $50, You're getting a code reader with a small screen, maybe live data on the OBD, two generic PIDs, engine speed, coolant temp, fuel trims, oxygen sensor voltage. Fine for reading and clearing a check engine light and doing basic diagnostic verification. In the 100 to 200 range, you're getting live data on more PIDs, freeze frame data at the moment a code was set, and sometimes bidirectional command capability for a few systems. That's the sweet spot for a serious DIY car owner. Above 300, you're into the semi-professional tools. Autel Maxicom, Launch X431, or their equivalents, which cover multiple manufacturers with something close to factory diagnostic depth. I'd rather see someone spend $80 on a decent live data scan tool than spend $0 on 15 ignition cycles and end up in a bay 2 weeks later paying diagnostic labor on top of the actual repair. Real green light. This is the reset the videos should be teaching, and mostly aren't. Tier 2. Situational resets that work partially. Reset number 5. Long-term fuel trim reset. Long-term fuel trim, or LTFT, is a value the ECM stores that represents how much extra or less fuel it's had to add to the base injector pulse to keep the exhaust oxygen sensor happy. Positive LTFT means the ECM is adding fuel to compensate for a lean condition. Negative LTFT means the ECM is pulling fuel back to compensate for a rich condition. On a healthy engine, LTFT sits within plus or minus 3%. A scan tool can reset LTFT to 0. Some videos recommend doing this after any minor engine work as a way to restore performance. The reality is that if the engine's condition is unchanged, the LTFT will drift right back to whatever value it was before the reset within a few drive cycles. If you clean the MAF and the LTFT was compensating for a contaminated MAF, resetting the LTFT lets the engine run a hair better while the ECM readapts for about 10 minutes. If the underlying issue is a vacuum leak, an aging oxygen sensor, or a fuel pressure problem, the reset does nothing useful. Situational. Useful only as a post-repair verification tool. Yellow light. Reset number 6. Generic OBD2 code, clear as a fix. This is where I want to distinguish between clearing a code and fixing what caused it. Clearing an OBD2 code makes the check engine light turn off. It does not fix anything. If a P0301 misfire code was set because a coil pack is intermittently failing, clearing the code turns off the light until the coil misfires again, which will happen. If a P0420 catalyst efficiency code was set because your catalytic converter is on the way out, clearing the code turns off the light for a few days until the ECM remonitors the catalyst and sets the code again. The videos that recommend clearing codes as a way to reset problems are technically doing something. The light does turn off, but they're treating a symptom, not a cause. And in some states with OBD2-based emissions inspections, clearing a code within a certain window before the test will cause the car to fail readiness monitors, and the inspection station will bounce you. Situational. Useful as diagnostic verification, harmful as a fix strategy. Yellow light. Now, Tier 3 is where the video ecosystem earns its reputation. These are the resets that get millions of views, precisely because they promise a free fix and deliver a broken module. 2 of the 3 below appear in the top 10 search results for ECU reset right now. I've seen 5 customer cars in the last 2 years brought in after one of these. Average bill $400 to $900 to unbrick what the reset broke. This is where Marcus was heading before he stopped and drove to the shop. Tier 3. Marketing Myths. Reset number 7. The Multiple Ignition Cycle Reset. This is the one Marcus tried. Turn the key on, wait, off, wait, on, wait, off. Some videos say 10 times, some say 15, some say 20. The theory is that the repeated power cycles will flush the ECM's memory and force a reset. Modern ECMs don't work this way. The ECM does not lose its stored codes or its adaptive tables just because power is cycled at the ignition switch. Some very old vehicles, pre-1996 OBD1 systems, had different behavior, and there were platform-specific tricks for reading and clearing codes with key sequences on those cars. But nothing modern responds to a repeated key cycle by clearing anything meaningful. What Marcus's 15 cycles actually did was wear the contacts on his ignition switch a tiny amount and prime his fuel pump 15 times. That's it. Myth. Red light. Reset number 8. Terminal to terminal short as a capacitor discharge. Some videos show a person removing both battery cables and then touching them together for a moment before reconnecting. The claim is that this discharges the electronics faster and gives a deeper reset than a simple disconnect. The problem is that some vehicles have modules that assume battery presence and behave badly when the cables are shorted together. On some cars, this can trigger BCM fault codes that require dealer diagnostic tools to clear. On other cars, especially older ones, it can backfeed voltage transients into modules that weren't designed for them. And if there's any charge stored in the alternator field circuit, connecting the two cables together provides a discharge path through that circuit rather than through the intended module capacitors. You get no additional reset benefit compared to a proper 10-minute disconnect with brake pedal discharge. And you take on a small but real risk of damaging something. Myth with a downside. Red light. Reset number 9. The ECU flash via key sequence. This one shows up in videos as a supposed secret procedure. Turn the key to the second position. Press the accelerator to the floor. Hold for a specific number of seconds. Release, and the ECU will flash to a new tune or reset to factory. Modern ECUs cannot be flashed this way. Factory reflashes require the manufacturer's proprietary diagnostic environment. GM's GDS2, Ford's IDS or FDRS, BMW's ISTA, Mercedes X-Entry, Chrysler's Y-Tech, plus a licensed dealer subscription and the correct calibration file. Aftermarket tuning requires a tuner like an HP Tuners or an SCT device with the correct license for your vehicle's ECU. No key sequence, no pedal pattern, no combination of switch positions can rewrite the ECU calibration on a modern vehicle. What some videos are showing is either an unrelated procedure that resets a specific adaptive value, the throttle body relearn, for example, being marketed as an ECU flash, or a demonstration on a vehicle where the driver's perception of a change is the placebo effect. Myth. Red light. Reset number 10. Radio reset for engine issues. Some compilations claim that resetting the radio or infotainment system will fix engine problems. The theory usually involves the CAN bus, or Vehicle Communication Network, and the claim is that a stuck infotainment can somehow lock up the ECM. Modern vehicle CAN networks are designed with fault tolerance. A misbehaving infotainment module cannot lock up the engine control module. They're on separate bus segments in most cases, and even when they share a bus, the ECM's real-time engine management runs independently of anything the radio is doing. Resetting the radio resets the radio. It does nothing for engine performance or drivability. Where this myth comes from is easier to trace. There are a handful of vehicles, some earlier Mercedes and some earlier VW products, where a bad infotainment module could trigger comfort system CAN errors that would generate irrelevant fault codes elsewhere. Fixing those codes required addressing the actual bad module. It never involved a magic reset. Myth. Red light. Reset number 11. Service interval reset as a maintenance fix. Every modern vehicle has a service interval counter that tracks miles or engine hours since the last scheduled service. When you exceed the interval, a service required or oil change light comes on. Owner's manuals include a procedure for resetting the counter after you perform the maintenance. And there's nothing wrong with that reset. It's the intended function. Where the myth comes in is that some videos frame this reset as a way to clear maintenance issues. Turning off the service light does not change your oil, does not rotate your tires, does not check your brake pads. Resetting the counter without doing the service is just lying to your car's tracking system, and the components you skipped are still wearing on their own timeline. Not a myth in the sense that the procedure is fake, the procedure is real. A myth in the sense that the outcome most compilation videos suggest, that resetting the counter fixes something, is false. Yellow light on the procedure, red light on the framing. Hard reject. The airbag light reset trick. I want to slow down on this one because it's the difference between a bad fix and a dangerous one. Every modern vehicle has a supplemental restraint system control module, the SRS module, that monitors airbag readiness continuously. If any part of the system fails a self-test, a crash sensor drifts out of spec, an airbag squib shows a resistance value outside the allowed window, a wiring harness develops a break, the module sets a fault code and illuminates the airbag warning light on the dashboard. The airbag warning light is not a nuisance indicator, it's a safety indicator. When it's on, the SRS module has degraded confidence in its ability to deploy the airbags correctly in a crash, either too late, too early, or with the wrong pattern. Federal Motor Vehicle Safety Standard 208 defines the deployment behavior the module is required to guarantee. When the fault is real and the light is on, that guarantee is compromised. Some videos show a reset trick, a key sequence procedure, a battery disconnect, a specific pedal pattern that claims to clear the airbag light. On some vehicles, some of those procedures will actually turn off the light temporarily. The SRS module clears its non-latched fault codes on power cycle. The light goes off. The problem is that on the next self-test cycle, if the fault is still real, the light comes back on. And if the fault is intermittent, the light stays off, while the underlying problem is still there. There's a second issue. The SRS module also stores crash history data in non-volatile memory. If the airbags have ever deployed, that event is recorded and the module will remain in a locked state until the module is replaced or the event data is properly cleared using manufacturer diagnostic tools. Some reset tricks claim to clear this locked state. They don't. What they do is corrupt module state in ways that can prevent future deployment entirely. If your airbag light is on, the answer is not to reset it. The answer is to have the SRS system diagnosed by a shop with the correct tools. Typical diagnostic cost is between $80 and $150. Repairs range from a $50 connector cleanup on the seat wiring harness to a $500 module replacement. Real-world context on how bad the reset advice gets. I've had 2 customers in the last year come in with airbag lights that a previous shop or a YouTube procedure had reset, meaning the light was off, but the underlying fault code was still active in the SRS module memory. On both cars, when we scanned with the correct SRS-capable diagnostic tool, we found stored codes indicating actual sensor faults. One was a seat occupancy sensor drift that would have caused the passenger airbag deployment logic to make the wrong decision in a crash. The other was a driver's side clock spring wear condition that would eventually have opened the driver airbag squib circuit entirely. In both cases, the customer had been driving for months, believing the problem was fixed because the light was off. The airbag warning light is not a check engine light. Check engine light on with a mild drivability complaint. You can drive to a shop, no urgency. Airbag light on. You are driving a car whose airbag system has flagged that it is not confident it will protect you in a crash. That's a different category of warning. Do not use a reset trick on the airbag light. Not once. Not on your own car. Not on anyone else's. This is the one where the reset industry crosses from marketing overreach into an active safety compromise. Hard reject. Red light with a warning. My own vehicle, because this is directly relevant. 2018 Honda Accord, 1.5-liter turbocharged Earth Dreams engine. 92,000 miles, Reno, Nevada. 6 months ago, I cleaned the throttle body. Real fix for a hesitant idle after some intake work. And the ECM's adaptive table was now wrong for the clean plate. Idle was surging between 600 and 900 revolutions per minute. Rough for the first 10 minutes of every drive. I ran the Honda KOEO relearn procedure exactly as it's documented in the factory service manual. Key to the second position, wait 10 seconds, key off, wait 10 seconds. Start the engine. Idle for 10 minutes with the AC off and no accessories. Short drive cycle with 2 full stops from 30 miles per hour. Come back to the garage. Let it idle 1 more minute. Idle stabilized at 720 revolutions per minute. No surging, no hesitation. The whole procedure took about 15 minutes end to end, plus the drive cycle. $0. No parts, no scan tool required. Just the ignition switch, a stopwatch, and knowing which reset was the right one for the specific complaint. That's the difference between a real reset and a marketing reset. The real one has a documented procedure, a mechanism you can explain, and a specific problem it solves. The marketing reset has vague promises and vague results. Marcus's Fusion. Follow-up. After his 15 ignition cycles didn't fix the hard shift, we plugged in the scan tool. 2 codes stored. P0742. Torque converter clutch stuck on. P0750. Shift solenoid A malfunction. The TSS solenoid, transmission shift solenoid, in the valve body was failing. That's a real mechanical issue. No reset was ever going to fix it. The repair on his transmission valve body was $340 in parts and about 2 hours of labor. $16 solenoid. Another one at $19. An intermediate valve at $22. Plus valve body gaskets and ATF plus 4. Post-repair, we perform the transmission adaptive learn, the real one from Tier 1 of this list, which is what a reset is legitimately used for. Trans shifted the way it did new. Marcus picked the car up 2 days later. Trans has been shifting normally for 6 weeks now. Total cost from walking in to driving out: $340 for parts, $150 for labor. Roughly $500 against a shop quote he'd been given elsewhere of $1,800 for a full valve body replacement. Wrap: 11 reset tricks, 4 that actually work when performed correctly and only in specific circumstances. 2 that work partially but don't fix underlying problems. 5 that are pure marketing. And 1, the airbag light, where the reset advice is a safety compromise you should never follow. If you have a specific reset trick a mechanic or a video told you would fix your car, drop a comment with which trick, what problem it was supposed to solve, and whether it did anything. I read the comments through the week. If a pattern shows up on multiple viewers with the same vehicle family, I'll pull that into a follow-up walkthrough for that specific platform. The Accord is going back in the garage in the morning. A customer is coming in with a 2016 Civic that needs the same throttle body relearn after intake work, and I want to run the procedure alongside a scan tool live data readout so I can show what the ECM's adaptive table looks like before, during, and after the relearn. That's the next video I'm putting together. Marcus's Fusion is back on the schedule in 4 weeks for a follow-up fluid check and a full inspection. He said he'd bring donuts. See you then.